live. Hello and welcome back. Hello. So, we are going to return to the question that we were looking at the other day, which is the encryption question on HackerRank. And the question is, I'll give you a brief synopsis. We kind of looked at it a few times the other day, and I was looking to program this problem in Clojure, and I kind of went over a whole bunch of issues. There was a perfect square question. I was wondering how do you write a binary search in a functional programming language, and then I was looking at how do we write how do we use transducers, and I kind of got hung up on these pieces in between of actually programming in Clojure. But I think I'm a little more comfortable now and probably should be able to solve it at this point. Let's go ahead and read the question, and then we'll discuss the solution that I'm looking for here. English text needs to be encrypted, and using the following encryption scheme. First, the spaces are removed from the text. Let L be the length of this text. Then, characters are written into a grid whose rows and columns have the following constraints. If you take the square root of the floor of the square root of L, which is L is the text, the length of the text after you've removed the spaces from the text. Then what you want to consider is the rows and columns are going to be ordered such that the rows are greater than or equal to, let x be this floor of the square root of L. Rows are greater than or equal to x, the columns are greater than or equal to the rows, and then the columns are bounded less than or equal to x plus 1. Or rather the ceiling of the square root of L. Not necessarily x plus 1. If x is a perfect square, then it's just x that we consider. So they give us an example. If man was meant to stay on the ground, God would have given us roots after removing spaces. You get 54 characters, and 54 is between, square root of 54 is between 7 and 8. So we can use 7 rows and 8 columns, right? 7 by 8 is larger than 54, but 7 by 7 is not larger than 54. So, yeah, we'll keep reading. So you write this string into a grid, and you've got to make sure the rows times the columns is greater than or equal to L. And if multiple rows, multiple different possible grids satisfy this condition, you want to take the smallest. So in this case, right, you really have a choice between 7 by 7, 7 by 8, and 8 by 8, and the smallest that satisfies that's larger than 54 is 7 by 8. So those 3 choices. And then what you do is you read off each column, right, with a space between, and that's the encryption scheme here. And you don't really care about the empty spaces in the grid. You just consider that to be sort of empty characters, empty space. Yeah, so that's the problem. It's a pretty straightforward problem, as it turns out, and I kind of meandered about quite a bit. More so I was messing around with like Clojure and understanding Clojure and getting more familiar with the syntax and structure and all of that, but ultimately this question is actually not too bad at all. In fact, you don't really need, I thought I might need a perfect square routine, but that was kind of silly. It's not necessary, as you can, as you don't need to know whether or not this is a perfect square. Like I said, you only really have 3 choices between 7 by 7, 7 by 8, and 8 by 8. Or if you consider the floor of the square root of the value to be, floor of the square root of L to be x, then you really only have x squared, x times quantity x plus 1, or quantity x plus 1 squared. Those are really the only 3 options you have, and you pick the smallest one that is still greater than or equal to the value you're looking for. Which, if it's a perfect square, the smallest one will always just be x squared anyway. So you don't really care, actually. Yeah. So, so let's go ahead. So yeah, so that's actually what this routine ends up doing. Is it gets the. So this is kind of interesting. This is like kind of a more involved routine. A simple reduction. I don't think I even need this filter. Oh, I see. Oh yeah, okay. I understand what I did. Right. So basically, what I said was, okay, take these three choices, and then filter out. Use a filter to remove all the choices that are not greater than or equal to L, and then use a reduction using a custom function that just checks against the area of these parameters. Yeah. I was going to use a transducer, but the problem with the transducer is that you need to have this reduction function you're going to use. You just have another arity defined, which is kind of annoying to do that, to use the transducer, so I didn't use the transducer. Just applied the filter transducer directly. Yeah. That'll give you your pair of that'll give you your that'll give you your pair of sort of rows, columns. What's going on here? Oh, okay. Pair of rows, columns that you're looking for, given L. Okay. So let's continue. Let's keep going. So what we want to do now is we want to interpret this string. So first things first, let's get the string that doesn't have spaces. So let's remove the spaces. Let me see if there's a simple routine in Clojure. String manipulation. I know there's splits, but let's see. String Clojure. Somewhere in here is this core or a string. There we go. String. Okay. Strings are objects. String be manipulated as the first argument to a function. Passing nil will result in no pointer exception unless documented otherwise. If you want to sequence behavior instead, use a sequence. Okay, strings are objects rather than sequences. Functions are generally not lazy. Straight to host methods where those are available and efficient. Functions take advantage of string implementation details to write high performing loop recurs instead of using higher order functions. Not idiomatic in general purpose application code. Okay. Okay, I see. Interesting. Function is documented to accept the string argument. It will take any implementation of the correct quote-unquote interface on the host platform. Java, this is character sequence. It's more general than string in ordinary usage. Almost always pass concrete strings. If you were doing something unusual, passing immutable implementation of character sequence, then third safety is your responsibility. Interesting. Okay. Peculiar. Provides most standard string manipulation and processing function that you'd expect in any general purpose programming language. Clojure script strings represented using the native platform implementation can be directly manipulated to lower foo Clojure string namespace. Gives you the ability to manipulate strings in an idiomatic way. Lowercase. Foo. something to keep in mind is most all of these functions take the string to act on as the first parameter, lending themselves well for use of the single thresh operator, as in this contrived example. Single thresh operator, yeah, it's an interesting one. It basically sort of pushes the results. It's like sort of a composition kind of a operator, and you sort of push the results from one operation to another. Reverse trim replace. So I'm thinking about performing a replace. I think that's what I want. That's kind of what I was looking for, is the different built-in join. Yeah, or use a join as well as a replace. Yeah, there's a whole bunch of built-in string manipulation functions that are quite nice, quite good. Anyway. I can use regexes. So what we're going to want to do is, it's a good thing this is hidden, this stream key. I constantly make the mistake of looking at it on stream. So let's use string replace then. See what this looks like. New S or RS, we'll call it, and we'll say this is going to be Clojure dot string replace S with, we're going to use white space, which I believe is it W plus, and we'll replace that with empty string, and we actually want to print this RS, so we make sure we did this correctly. Let's find the replace. Let's see, match replace S match replacement, and we want white space. What is the Clojure string or even Java regex spec? Special characters, but just specification. Because this is going to use Java underneath. Didn't compile, huh? I don't know if they have white space character. That's kind of what I'm looking for. API. What character classes? The OR, got that. NOR. It's like official docs. I don't know. Range class. That's fine. Union. Got it. What are these? Two more character classes? That's weird. Intersection. Common elements. Interesting. Intersection only has 4 elements. Huh. Subtraction class. Oh boy. Negate. Predefined. We're looking for is digits. There's white spaces S. Okay. So it looks like Java uses S. It's kind of different between languages. Also looks like it was /S. I forget how to look up the particular define function. Not a function. how one looks up each. There we go. Have a nice day. Okay, nice. It's working. It's working. Okay, so that's the string replace we want. And then what we're going to want to do is have a function that, so we can put this towards the bottom here. This doesn't need to be at the top. I want a function what it's going to do is take a string, so S, or yeah, we'll call it S, or just some string, I don't know, call it SS, and it's going to return column. That's a string, column string from S. It's also going to take a row column pair to define the grid. So this is going to interpret, this is going to extract and an index as well, row column index. So this is going to be column string. What this will do is it's going to, given an index, which column, and given a string, and given the grid, the row column, interpreting the string as a grid, it's going to return that particular column string as if you interpreted the one-dimensional array or one-dimensional string as a matrix of sort of left to right, top to bottom lines of characters in a grid. Yeah, that'll give this subroutine will give you that, return that. So what this is going to do is the index is, so we can do this. So these are the arguments, right? And then we want to define so there is a sequence of values that we want to look at, and we want to iterate over those values. That sequence is going to start from the index of the row, right? Start from the beginning, and then we're going to add row column number of times. Excuse me, we're going to add the column size, the number of columns, we're going to add that row number of times for each row. We're going to add that value and process and get the next character. So I think we want I want to say we can use a list comprehension here. How it's going to look is like, let's just get all the characters, right? So it's going to be something like it's SS of val, where val is going to come from, or rather, I wonder if we should use a let here. So we have a binding for val, and then we've got SS of value. And let's use, it's going to be x in range of, so okay, we said for each how does this work exactly? It's going to be initially, it really should be range of, for each row, right? Yeah, I think this will work. For each row, row. All right, this will do a list comprehension over all the values of the row in the rows. You're going to bind val to index times the value x plus no, it's going to be actually index plus it's going to be whatever x is times the number of columns. Yeah, okay, kind of funky, but that's what we're doing here. You don't actually need to bind this either. Okay, ye old list comprehension. That'll give us what we're after in terms of characters. Now we also want to concatenate using string, and we want to return that. Okay, I think that's what we want. And let's just print the first character string, column string rather. We're going to use rs, we're going to use row column of count of rs, right? And then we're going to use index 0, first column. Okay, let's see what that looks like. Let's see if that gives us what we want. Gosh, I feel like it's taking me so much time to do this. Hi, William. Hello, Akshay Deep Giri. Hope your day's going well. Welcome, welcome. Hello, hello. How are you? How are things? Akshay. Hello, hello. Welcome. What did I do? 3 arguments compiling. Shouldn't this list comprehension give me 3 arguments? Yeah, getting familiar with these. Also, forgive me if I didn't respond for a while. I don't know. Do I have timestamps here? Hold on 1 second. Let me make sure I get timestamps going. Some people say hi. I don't ignore them. Just one moment. Does this not have timestamps? Toggle timestamps. There we go. Okay, there we go. Timestamps. Okay. So what we want now is sequence expressions, body expression. Yeah, the binding is the sequence expressions. And then the body expression, yeah, shouldn't this be, do I have to return this maybe? Oh, that's why. Oh, yes, of course. Okay, I got it. That's my mistake. Completely forgot. I completely forgot. It doesn't work like that in Clojure. Yeah, the nth is what we want, of course. Of course. Let's see. Oh, and it's Clojure, man. It's Clojure. It's not. Maybe I should use the let. So maybe that's one thing I'm kind of. Yeah, use a binding. Okay. Val B. You kind of. I don't know. I'm kind of conflicted about this. Alright. Let val be. Yeah, because in Clojure you've got everything is prefixed, prefix notation. So that's it's kind of funny. All right, how do we do here? Okay. Hopefully the binding works as I expect it to. I don't know if it does. No. No. Long to function. Oh. We can try. Yeah, we can try this. I don't know what happened with that. A second time, I've kind of tried to do something with a binding, a let binding, and it just didn't work as expected. I think it's the let that was the problem there. No, wasn't the let. Oh, something else. Okay. Well, in that case, go back. So, what part is not compiling then? Let's see. Just do a sanity check, make sure. Okay, so that's fine. And what we want to do is, let's just define the function and not try to call it. I'm not sure if it's the definition of the function that's causing issues, or if the call of the function that's causing issues. It could be a few different things. Okay, so the definition, it seems okay. So what was the compiler error? So we have, if we do, let's try this. I happen to know that this row column should return, I think, with, let's see, let's have a nice day. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 characters. We can do a 4x4 or even a 3x4. Actually, 3x4 is probably best. So we'll say 3x4. Let's do this. 3x4. Oh, yeah. Okay. Let's also print this while we're here. And before we do that, yeah, okay, let's see. Just see what it does, what happens. If we get a compiler error or not. Let's see. Let's see what we get. Let's see what we get. Wrong error, okay, wrong answer. Long cannot be cast to I function, alright. And it could be a few different things. Let's just see if, what about this? So it is this function. What am I doing wrong? Three, four. Yeah. Interesting. So this works as expected, but this is sort of a problem. And why though? Define function, column string. We've got 3 different arguments. All right. This destructured in here. And where was the error again? It's very unusual. Very unusual. Main cast exception long cannot be cast to function compiling. Now, why is it trying to do that? What's trying to convert some long into a function? What's going on? What is it doing? What if we do this? A, B, C. Is it an issue with the parameters that I'm giving this? I wonder if it has something to do with, yeah, we'll find out. Interesting. So it's not that the parameters aren't getting destructured. Like, that's fine. The parameters are okay. I think maybe it's the function itself has some issues. What exactly though is the issue? Supposed to return this value. I wonder. Like, what is, okay, let's try this then. What does this give you? So I realize if I'm printing twice, look kind of interesting, I guess. Output. Parentheses. So it's got to be the list comprehension. It's got some issue. Yeah, I'm still kind of getting familiar. You know, still getting kind of finagling a bit with these things. Not totally comfortable with Clojure yet, I would say. What is this out? What is this output? That's so strange. I don't know, man. Huh. Alright. So the issue is somewhere here. This function is not quite right. Now, if I remove all of this stuff, and I just say, you know what, maybe this is what we need to do? I don't really know exactly how the list comprehensions work in Clojure. Oh, excuse me, I can actually create the binding form right in here. Oh, interesting. Oh, wow. Okay. Okay. Well, huh. Okay. It's kind of wild. I kind of like doing this as well. So we can do another binding form here and say, get rid of this let. Now the question is, what does this do? Long function? What am I missing here? Not found. That could be also 0, I think, or just empty string. I'm not sure if that, I don't think that's the problem. That would really kind of blow my mind. Collection index. Oh, is that why? It's not a collection. Doesn't it work for, I thought it worked for strings though. String, yeah, what is? Like, if we just used, I don't know, 10, right? Something like this, what would this give us? Or even just the value, val. How about val? What is going on? What is going on? Something strange is happening here. Something strange in the neighborhood. I don't know what is happening here. Something very odd is occurring. I just want to use the list comprehension. And I'm missing something here. Something's not quite right. End, start, and stop. Yeah, this is what I'm using, no? It's a sequence of numbers. So shouldn't this loop through the sequence? XX. Sequence expression. This is not how we use the for syntax. Isn't this it? X range, Y range, and there's XY. Oh, compiles now. Okay. Neat. Okay. Well, that's bizarre. What the heck? What? Oh! Oh, I didn't even realize it. Oh my goodness. Wow. I'm so hung up on the other details that I didn't even notice this. That's pretty funny. Oh my goodness. I didn't realize that. It's babbling on about prefix notation and just completely missed that X is not a function is exactly correct. When you're dealing with HackerRank, the compiler messages, is it HackerRank? I forget exactly what it is. Sometimes the compiler messages just kind of miss the correct line. I forget why exactly. I don't know. I don't remember what the deal is. But yeah, I probably could have caught that a lot sooner. Oh, I feel so silly now. Jeez Louise, man. Let's go back to original. Oh man, that's, well, yeah. You know, these are the kinds of things when you're getting used to a new language and a new syntax. You know, next time I'll be more keen to figure out where that is. All right, let's see if this let works though. I'm curious about that. I realized I could put a let, I realized I could put a let binding right in here instead of creating a new let. But I'm curious if this works. What this will do. Very interesting. Very interesting. Expected output, debug output, lazy sequence. Nice. Oh. Uh-oh. Huh. It's a lazy sequence. String. String over sequence. Maybe I need to use join. Let's try join. And then maybe sequence. I don't know, what's this one? It's str. Yeah. We would need to use a like a destruct. What do they call that when you take a sequence and you sort of, I guess, destructure it. Destructure the sequence. Destructuring the string. A few characters from it. No. Can you destructure the arrange? Maybe. I wonder. If you sequence. You need to get the first character and the rest of the characters. If you do it this way. Alternatively, you can use a join, I think. Sequence collection. What does sequence collection do in this instance? Kind of curious. Let's put sequence here. I wanna know. Can you show me? It's just taking me a lot longer than I thought it would. Just saying. HAE. Oh, okay. So interesting. So you can sequence this. If we throw a sequence in there, I think this will do what we want. Maybe? I don't know. I wanna know. Can you show me? Do you want to put a join in there? Oh, not quite what we're after. Nope. Clojure.string join. Joining over the list comprehension. Oh, okay. That's not what I wanted. All right, 4313. Oh, really? Oh, okay. Hey, it works. Cool. Very cool. And let's remove this let, or let's move this let into the so we have a few less characters to work with. Let's move this let inside of inside the what's that called? Let's do a few things here. Let's do it this way. Make this thing a little more manageable. Got this join over this for loop. Unmanageable, but make this a little, what do they call that? This is a binding. Yeah, move this into the binding. Let's see what this looks like now. So in theory, this would be like a lot faster to write, but like I said, I'm still kind of getting familiar with Clojure and its syntax and all of that. I can also remove the let altogether. Don't actually need the let there. Don't need that binding. That I think would simplify things a bit. Make this all one line, I think. There we go. Nice. Now, isn't that simple? And then we can do here. Now that ought to give us what we're looking for. The first column printed. Oh no. Wrong number of args, wrong arity. Oh, wait a minute. Whoops. Oh, we do still need the binding in the 4. Let's do this. Let's go all the way back. That's my mistake. Thought that looked a lot more concise than it should have been. Thought that was maybe a little too concise, a little too terse. Whoops, whoops. All right, and now we can say use another list comprehension here. We can use another join for what we're looking for. Almost exactly the same thing. So what we would do is say define. Now I wonder, these defs, I think they're contextual, right? Like I don't need to use lets or anything here. I'm kind of conflicted about using defs and using lets and all of that. When you define within a function, I don't think it's global. I think it's within the function namespace. I don't know. Like I'm kind of concerned about using these defines. Kind of want to look that up. What exactly happens when you use Clojure def? Because I've seen that in other code, but I'm not sure if that's like idiomatic or the correct way to do it. A global variable with the name of symbol and a namespace of the value of the current namespace. So this is a global variable. It's not really good. That's not really good. Local var. Like I don't want global. Yeah, that's actually I don't think that's the right way to do it. I have been using these, but it's not really correct, I think. So I think because they're global variables, I think these functions that I'm defining are actually they're not really nested functions the way that I would like them to be. They're actually being defined within the namespace, the entire namespace. So like I can actually call this outside of I can actually call this outside of the, I think. This is gonna look kind of weird. Two things to check. Can I call this within, in other words, do I need to call this first? If you understand what I'm getting at here. So if I call this first, does that then call this function and then it's available and then call it? Or can I call this directly? Like what happens if I do this? I'm kind of wondering about that. Define n, if that's the sort of correct and/or idiomatic way to do things here. Okay, 47.5. Oh, let's do this. Idiomatic Clojure, man. Idiomatic Clojure. Very interesting. 47, 48. What? Unable to resolve a symbol SS. No. Alright, yeah, we moved on to something else now. Moved on to something else now. I think you would use a let instead of true. That's interesting. So yeah, you can call this outside of this context. That is kind of interesting. Oh. Wow. Now if we remove this, we still be able to call it? That's another question. No. So that's kind of wild, man. That's kind of wild. So I guess it's not correct to use these defined functions. How can we do like inner functions, like local functions? Because you're going to be mucking around with the namespace. Let function. Okay. So let's go with, we can look at this one. Pass to or return from others, primarily pure functions, no side effects, the same inputs to the same output. Defines a named function, multi-arity functions, periodic functions, anonymous functions. I want local functions, define n versus fn, contraction. Anonymous functions, gotchas, applying functions. Oh, we probably want to apply string then. Could alternatively, instead of joining over here, could alternatively use apply. I would like to try that. Instead of joining. Kind of curious what this looks like. Excuse me. Plot, shape, coordinates is x, y. Plot x, y, shape, first coordinates, second coordinates. You can then say apply plot x, y to shape coordinates. First coordinates, second coordinates. Oh. How would this work? What is this? First of coordinates, second of coordinates. Oh, yeah, okay, I see. Right, that makes sense. So coordinates becomes, so you call this function with these arguments, and then coordinates become, okay, I understand now. This actually sort of extracts everything from the sequence. So there actually is a function for that. Okay, I was wondering where that was. I needed that. Locals and closures. All right, we need to read this. This is exactly what we're dealing with right now. Aha! It worked. Cool. Very neat. I like that better. It's a little more terse. You don't have to invoke the string. Something in the string library. Neat. Right, but this is incorrect using these defns. these really should be let ends, I think. It's bindings. What are we doing here? Locals and closures. Okay, let. Bind the symbols to values in the lexical scope. Lexical scope creates a new context for names nested inside the surrounding context. Names defined in a let take precedence over the names in the outer context. Code that uses this name. Alright. So it creates a new context, but everything's got to be nested inside that context. That's the thing that's tricky about this let. So each let can define 0 more bindings and 0 more expressions in the body. Let expression creates 2 local bindings for x and y. Expression x plus y is the lexical scope of the let and resolves 1 and 2 outside the let, so I'll have no continued meaning unless they're already bound to value. Right, so this is what we want, but so you have to put everything in a let scope, which kind of makes things a little more complicated. But that's what we should be using for these let and let fn values or functions. Messenger function takes a message argument. Here the defn is also treating lexical scope for message. Only has meaning within the messenger function. Within that function scope, the let creates a new scope to define ABC. If we try to use A after the let expression, the compiler would report an error. Nice. Closures. The fn special form creates a quote-unquote closure, closes over the surrounding lexical scope, message A, B, or C above, captures their values beyond the lexical scope. Define n. Closes over greeting. Greeting provided here, then goes out of scope. Greeting value is still available because hello where is Clojure. That's interesting. Huh. Actually, that doesn't really explain much about closures. So you can capture the value beyond the lexical scope. It's kind of awkward. Don't fully understand that. You can test your knowledge. That's great. But let's go ahead and continue. So what we want to look at is let fn, and some folks describe, yeah, this is really what we're looking for, locals. So let versus let fn. Vars in the global environment. Kind of want to read this too. This, I think, is what we need to operate correctly here, to use local functions, which I like to do. Let versus let fn, if we find local functions in Clojure. When in practice, should I use let fn versus let for defining local functions? What about cases where I want both local functions and local not functions? Okay. All I need is a local function or 2 or 3. I'll let fn them. If I needed to let a mix of functions and non-functions, just use a normal let. Let fnning and letting would be a very verbose way to do this. Need mutual recursion through your local functions. You have to let fn them either way. Use them when you think it looks better and when it's convenient. There are no hard and fast rules for using either, they're just tools. Nice. And needed to use let. That way you can define a set of both functions and non-functions. A single form, and even refer back to previous definitions. Let fn is really only needed when you want to define multiple functions that recursively refer to each other. Let won't work in this case because it doesn't support recursive references. Interesting. Okay, so that's the hour already that we were going to use. Wow. Geez. All right. Let's finish this problem and then we'll end. So we're not going to use defn is not what we want. We want let fn. So let fn. Let fn is this function, and then you actually don't even need this anymore, or we could use a let, right? Hold on. So if we just use a regular let, right, and then we use this. Okay, well, it's gonna take some time, but that's okay. And now we want to say function. Okay, we use a let. Get all this stuff here. Actually, it's not going to simplify things. It's going to make it more complicated. So the idea would be there's a let inside of all of this, which contains everything, and then calls this perfect helper function, which is actually defined. It's not a defn, it's fn, and it's going to be called, the name of this anonymous function is going to be bound here. I hope that works. It's going to be this function that looks like this. And then we're going to bind these, have these local values that are set here. So this is destructuring in the function, and then this is a let within the function. So does this compile? Let's go back to this print line for, we had perfect square, question mark 64, and then we had perfect square helper of n start end. Right, let's see what that looks like now. So this is kind of unusual. It's kind of unusual. Clojure let did not conform to spec. Nice. Okay. This is gotta be in the binding. That's kind of wild, man. That's kind of wild. Should get an error though. Perfect square helper is not in there, but we did get true. Wow, that's crazy. Okay. So this is what we wanted. We wanted this let to define a function that only exists in this context, and then this function is used in this context, and we return, right? This gets returned from the let, which then gets returned to our defined function. So this gives us our local function. Now what we could do alternatively is let fn. Yeah, what's interesting is that this context within the function actually is kind of necessary to define these variables. So we could even do this though, let fn, which I think simplifies this a bit. I hope. Function specs, expressions. Function spec, yeah. So the let fn with some functions defined inside. Yeah, so you have function specs in there. So you get let fn, and then you still need to use this, but here you can define the function. This is actually, so it's a perfect square helper with this start and end, and then this internal let, which defines two more values, and you have your recursive, right, logarithmic search, and then then you call this function here and close your let. Now this should be deleted. This actually should just be right. So this is a function spec, this whole thing, and then now this function is available to this call. And we should get this should compile as well. And this can be, I think this is fine to be here. You kind of maybe want like this kind of thing going on, or even try that. That may be better, right? And everything else lined up this way. So your function spec is here. It's a local function. Local context. Kind of wild. But this should give us a compile error as well, because we can't call oh, I don't know what happened here. Oh, we didn't get this didn't work. Oh, that's interesting. Uh-oh. What? Said I was going to finish this problem, but I'm kind of how to create iSequence from symbol compiling 3.5. 5? Oh, I think it needs a okay, it needs a enclosing okay, needs to be enclosed. I think I get it. Parentheses everywhere, man. Neat. Cool. So that's what letFN looks like. You could, in a normal let, also just define this as it is. Like, you don't actually need this sort of extra syntax for defining multiple functions. It doesn't really matter, I think. So what other folks are saying, like if you just leave these out, it's actually a little bit simpler. It's actually a little bit simpler if you do it this way. It's the same thing. It's not as oh no, oh, excuse me. That doesn't conform to spec. Uh-oh. I'll take it back. Oh, yeah. No, I'm sorry. You can't, yeah, okay. You still need to make this a function, this thing. I'm sorry, take that back. You could name the function this way. This is almost the same. Yeah, this is very similar. So the letFN just means that all of these are going to be function specs, which is just the function wrapped, within parentheses. Whereas if you do the normal let, you could just name a function, and it's the same thing. This anonymous function. The local name is here. Yeah, there you go. Okay, cool. Very cool. Let's go back to the letFN though. I like that. Kind of prefer that. Very interesting. So that's how you properly define a local function in Clojure. A little more verbose than I'd like to be. Kind of was hoping things would be a little more, a little cleaner, a little bit like more terse, I suppose. But there's one way. All right, so that means that we want these local functions to be defined appropriately. So let's use a normal let for this one. And there's going to be a whole bunch of different bindings. And we're going to use row column function. And this we can put in here. Right. Probably want, yeah, I guess this is fine. The function name here. Also these being on one line is kind of makes this a bit awkward. You could, yeah, all right. My formatting's all messed up now. And this is a local function as well. So actually, this even has its own local function. Another local. This local function has its own local function. Wow. Wow. Which really should just be a binding then, right? Cool. I can do that now. There we go. Could maybe do this. Yeah, like that. That's good. This should be here. This should be here. So, wow. Okay. So we build this local function here, and inside this local function we've got another let, which defines yet another local function. And so we can use this custom min to filter here. Okay, interesting. And that's row column. It's the first function in our let. And we want another function in there, which is the next binding. Which is going to be the column string name applied to this function, which is fine, which is takes these arguments and builds the strings. This will get us our column string. So we've got this row column function, we've got this column string function, and then finally we want to define yet another symbol locally, which is rs, which will be apply the string replace to s, which is supplied here. And last but not least, we want to return, which is this last piece here. Looks something like this. After defining these functions, we can now use them, put them all together. And it's going to look something like, we can do L as well, which is, or just, yeah, actually it's fine. We can leave this, leave this where it is. Let's count rs. Maybe we want to, maybe we do want to bind something to the size. I don't know. Well, I could say RC is, we could bind it once. I think that's not a bad idea. So we can make this RC. So there's going to be a join. It's going to be a list comprehension of where we're going to go through all the columns, and we're going to say, let's, on each column, on each X, we're going to call column string of, it's going to be RS, row column is RC, and the index is X, and each row, we did list comprehension, right? This is what we return at each step, and then we're going to join with a space. So Clojure join. Also, this should return. This should also return an empty string if we can't find a character. And this is going to give us a join over. Now, if we look at Clojure join, kind of a lot of reading we got to do. We'll come back to this separator. Separator comes first. Collection is second. Okay. Yeah, it's kind of a lot of reading I got to do, but we should do a few more problems. Let me end stream as soon as possible though, so that way the video is relatively short or shorter. It's not super long. You got to watch me finagle with different, I guess, different ways to define your functions. You know, keeping them local. That way they're not sort of strewn about your program. Column in this context. Oh, excuse me. Oh, okay. That's kind of awkward. You could do RC. Maybe it's better. Yeah, actually bind a row and column here. So you have column, and then instead of RC, you can just do row column. Or rows columns. It's interesting. RS being replaced string. Hey, got him. Cool. YOLO. Neat. Solved it. Took a while. I think we got a badge too. There we go. 6 star. Neat. Neat, 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 neat. All right. So we have, yeah, see, that seems kind of involved, you know, this whole thing. I think it is functional. It's just had a lot of pieces to it, I guess. A lot of stuff that I was learning and I'm still learning about. But overall, not too bad, not too shabby. It took a while. It took hours, this whole thing. But in theory, like if I was doing this in Python, you'd probably do it in 15 minutes, a few minutes, maybe even less, a couple minutes. And then in Clojure, obviously this looks kind of clunky, but I think you can do it pretty quick too as well. If you like, this isn't that complicated. I kind of broke it into different pieces, and it wasn't too bad. More than anything else, I think I just got stuck on different parts because I'm sort of not so familiar with the language. But also, this is obviously, I'm kind of trying to format the text in a way where it kind of flows, where you can read it reasonably. You know, here is obviously where we're defining all the stuff we're going to use, and then you sort of do it piece by piece. You get this function that you want to use, and then you get this other function, and then you know you can perform the replace in one step, and then use this function that you defined already to get the rows and columns you're going to use, and then finally put it all together at the end and with a join over all these column strings. Yeah, not too bad, not too shabby. I think that's okay. I think that's okay. And yeah, not use defn for these things, or define. Don't define the symbols. Like you see here, they defined each of these. I think it should be in a local context. Oops, undo that. It should be in a local context, so we're not like polluting the names, polluting the namespace, as it's called, and as it's referred to in other languages, like I think it's JavaScript. A friend of mine showed me that. If you look at one of my videos, I use the matrix kind of background that prints text and it kind of flows in the back. A friend of mine coded that up, but he explained to me that what you ought to do is encapsulate your JavaScript code in sort of like a function call, and like an anonymous function call. And the reason for that is that all the local variables, all the variables you define, like I didn't understand why he said to do that at the time. This is a very good example of why. This makes it very clear. And the reason is because if you're just running the code, the JavaScript code, every time you write var or let or what have you, where it defines a variable, it'll define it in that namespace, I think. It won't necessarily be in the local context. So you can encapsulate your entire functionality in an anonymous function, and that'll actually bind all of your variables that are, I guess they'd be variables that are sort of global with respect to that particular JavaScript block. Maybe that's why he did it. Now I'm thinking about it, like, wait a minute, hadn't seen that in other code, because other code was using React, where it was sort of already encapsulated. All of programming would be inside of one sort of lexical scope, like a component. So basically, if you start defining like sort of global quote unquote global variables that are kind of outside the lexical scope, if you encapsulate your whole program in an anonymous function that's been called, then all of those variables are only global for that particular like scope, for that particular page of JavaScript, something like that. It's kind of confusing if you understand if you can follow all that. But the idea is that, like, yeah, you have these variables you want to define, and they're kind of like static, global, pseudo-static, pseudo-global, but they're only supposed to be for that particular piece of JavaScript code, that page of JavaScript code that you're working on, not for the whole JavaScript program. You can wrap everything inside of a giant anonymous function call, more or less. Although React sort of style of JavaScript is really more of you would use components, and everything gets kind of wrapped in components. So I think it's something also I didn't fully understand about JavaScript and web browsers and HTML and CSS and all of that, is that for the longest time I didn't really understand, is that like all of these things are sort of tools that the browser uses to produce the web page, and the browser is actually a C++ program that has millions of lines of code, and it does some funky things, and it actually uses the JavaScript code and the HTML code and CSS code to build the page programmatically, which is kind of involved, kind of interesting, kind of complicated. But like, I didn't really understand that, when I was at uni, and I think I had the wrong idea, because like you might think to yourself like, well, what's like the entry point to the JavaScript? Like, how does this all work? I think JavaScript code does have, basically the browser actually runs the code from it parses the HTML and will run your scripts through the HTML via the HTML calls. Yeah, that's like the entry point. So it gets a little confusing, and then obviously the JavaScript is packaged with other JavaScript, and you can call other JavaScript code using, I think, import export, something like that. I think I said lets the browser know there's code elsewhere. Yeah, like following your way through a JavaScript program in the first place is like not the most obvious thing, which I haven't done that in a while. But anyway, I'm kind of rambling on. Let me end stream here so that way this video is somewhat somewhat blocked off. But that's the solution to this problem. Pretty easy problem overall. Just kind of a lot of stumbling blocks writing this in Clojure. Kind of a lot more verbose than I was expecting as well. Given that Clojure is kind of sort of given over to doing things in kind of a terse, sort of sequential, functional way. Anyway, okay, yeah, so let me do that. Let me end the stream. So thank you for watching. Talk to you soon.